So this is Geometry 4.8, the summary of triangle congruence. What we're looking at here is making our plans for our proofs. What's the given information? What are you trying to accomplish? What method are you going to use to do that? So we notice that EF, segment EF is congruent to segment GH. EF gets a tick mark. GH would get a tick mark because they're congruent. It really doesn't matter how many tick marks, but we typically start with one. EH, segment EH is supposed to be congruent to segment GF, so we'll give them a different number of tick marks. And then we have to find something else. You've got to try to identify, do you know you have right angles? Do you know if you have an angle bisector? Do you know if you have a reflexive side? Do you know if you have parallel sides? Whole bunch of stuff that are options here. Anything's up for grabs, but we just got to try to pay attention to our picture and see what's given to us. When we look at this one, if you trace out, you can use your fingers, you can use a highlighter, you can just use your eyes, and you trace out one triangle, and you trace out the other triangle, you'll notice that both triangles share the same exact side. Same exact side is being shared. So that would be called the reflexive property. And that would get a different number of tick marks than any of the others. So, some people get confused, and when they use their letters, side, SS, and then they go into the other triangle also. You have to stay in just one triangle. Don't jump into the other triangle. We have a 1 ticker in both triangles, a 2 ticker in both triangles, and the shared 3 ticker in both triangles. So that would be considered side, side, side. We come down to our next example. Angle S and angle B are right angles. So we put the box in the corner. Now we can't jump to conclusions. Listen to this carefully. Just because we have right angles does not mean that this is going to be RHL. It's possible that those right angles are going to make congruent angles. If we had the side information around them and the angle was the included angle, we could still consider this side angle side. It would not be considered a right triangle. That's not how we're using it. It'll depend on what information they give us. So the other information they give us is that MS is congruent to MB. That's all the information that they give us. But if we trace out both triangles, you'll see that they share this side in between. That's called the reflexive side. Now I do recognize that they've given us 2 S's and the non-included angle. So it kind of looks like SSA. SSA is not one of the methods that we can use to prove triangles congruent. But if we focus on this as being a right triangle, I was skeptical in the beginning, but it did turn out that way, that this is going to be used as a right triangle because they're giving us the hypotenuse and the leg is going to match the hypotenuse and the leg of the other right triangle. So RHL. Right triangle, hypotenuse leg. Number 3. Segment OG is perpendicular to segment BL. OG, you got to use your eyes. BL, they are perpendicular to each other. That means that they are forming a right angle. Remember, don't just automatically think right angles are going to be right triangles. It's going to be RHL just because of the right angle. That's not always true. Let's see what other information they give us. So that was our perpendicular. We label the perpendicular by showing the box. That's the only symbol that you'd use for that. OG bisects angle BGL. A lot of people have been making a mistake here when they talk about an angle bisector. They think that the segments are congruent. That's not what they're mentioning. They're saying that the angle is getting split in half. So if this is a big angle, it's going to get cut into two congruent parts. That makes these two angles congruent to each other. And then if we trace out the two triangles, you'll see that this segment would be the same for both of them. That's the reflexive side. So the order that we have, both triangles have a single curve angle. Both triangles have the one-tick side. And both triangles have a right angle. Right angles are congruent. So angle, side, angle. We look here on our next example, and it says that angle U is the midpoint of CN. Not angle U, I'm sorry, point U. Point U is the midpoint of CN. So that means the midpoint is going to divide CN into two congruent parts. Now, just to mention it, do understand that just because U bisects one segment does not mean that it has to bisect both segments. It does in this case because they tell us, but we can't assume that. Just because it bisects one does not mean it bisects the other. If we had the big letter T, our vertical line could be bisecting our horizontal line, but clearly our horizontal line is not bisecting our vertical line. So just because one segment's bisecting the other does not mean that it's shared in both directions. But in this case, you're right, it is going to be, because U is the midpoint of PT. As long as it tells us that, then we know that the midpoint divides a segment into two congruent parts. What's the third bit of information that we're looking for? Do we know anything's perpendicular? It almost looks like that right there. They almost look perpendicular. Do we know if we have parallel lines? Do we know if we have a reflexive? Do we know if we have vertical angles? If we form a big X, if you form a big X, then you're going to have vertical angles on either side. Those are congruent to each other. Because as those angles would change, you can notice that both angles are getting small or both angles are getting big. So vertical angles are always congruent to each other. So if we notice we have the big X and the angles we're looking for are our vertices of the triangle, then those are going to be congruent. So this is going to be side angle side. Some people make a mistake and they say that this is side angle angle. But do notice that you went into the other triangle. You have to stay in just one triangle. Both triangles have a one ticker side. Both triangles share or have a one ticker angle, and both triangles have a two ticker side. They both have a side, an angle, and a side. Okay, this next one, we're going to have to come up with what triangle is congruent to PAC. Before we do that, let's find all the parts that are congruent. Segment PA, that's going to be congruent to segment PU. Segment PC bisects the angle UPA. So if it bisects the angle UPA, then those two angles are congruent to each other. So now that's two bits of information. Both triangles have a side that's the same. Both triangles have an angle that's the same. What's the next bit of information that we know for sure? This does look like 90 degrees. But there's no indicator, any requirement why that has to be a right angle. So no, I don't think we're going to focus on a right angle. The side that they share, that's called the reflexive side. That is definitely the same. PC in the top triangle is the exact same length as PC in the bottom triangle. So side angle side is how we're going to do this. Now let's figure out the names of the triangles. This first triangle is being named PAC. So we started at the point, we went out to the edge, and then we came back to what almost looks like a 90-degree angle. We have to use the same pattern over here. So we're going to start here at the point, which is P. Then we come out here to the far corner edge, which is U. And then we go back to about where that close to 90-degree type angle is. So PAC, triangle PAC, is congruent to triangle PUC. All right, next we're looking at parallel lines. These parallel lines, I have QI. So I look in my picture for the Q, and I look for the picture where the I is, and it looks like this I got away from us a little bit. That I belongs over here. So QI is parallel. Well, you got to be careful on how you label your parallel. You want to be sure to put an arrow on it, not just a tick mark. Just because they're parallel does not require them to be the same length, does not require them to be congruent. It does not give us an S. Those are just parallel. That is not S or an A. That doesn't help us prove the triangle is congruent yet. So what you want to do, you can either use a marker or you can use your eyes. trace it out with your finger. Those are your two parallel sides. Now you want to come up with a segment that is part of both triangles. So this segment is not part of both triangles, so we're not going to use it. This segment is not part of both triangles, but this one here is part of both triangles. So this is made a zigzag. This corner of the zigzag creates an angle, and this corner of the zigzag creates an angle. And that's all because the lines are parallel. We know those angles are congruent because the lines are parallel. If two lines are parallel, then alternate interior angles are congruent. We also, from the given information, know that angle Q is congruent to angle N. And what's our third bit of information? Something that we don't have labeled yet. We notice that this segment in the middle of the two triangles, if you trace out the one triangle and if you trace out the second triangle, they both share this segment. That's the reflexive. We call that reflexive, POC, property of congruence. So we would use angle. We have two angles, so angle, angle, and the side that is not between those angles. We can't use the arrows. We have to use the tick marks. So angle, angle, side. So now we have to name the triangles. So the first triangle tells us how we have to do this. QUI. Q has the two tick marks. Looking in the other triangle, N has the two tick marks for the angle. So N has to go first. Then we went to U. That's the short distance away. So from the N, we're going to go the short distance, and that's the I. Then, in our main name, we went down the shared reflexive side to point I. So in this bottom triangle, we went from N to I. We have to go down our reflexive side to U. Try to be sure that looks like a U and not a V. So that would be NIU. Okay, just a couple left. Go ahead, pause the video, and you work on these three. And then come on back, and I'll walk you through it. All right, we're back. We have B as the midpoint of AE. So we put our tick marks on there. Remember we discussed earlier, just because B bisects one of the segments does not require it to bisect the other segment. We know angle D is congruent to angle C. And we're making that big X in the middle. So we have vertical angles. So we have ABD being congruent to EBC. Triangle EBC. Using the angle, angle, side theorem. Questions about that? Moving to our next example, We know that angle M is congruent to angle N. Angle MOP, you've got to use your eyes. You might trace out that angle from M to O and O to P. There's your angle. This is an angle, so we have 2 tick marks there. And NOQ, we put 2 tick marks there. Plus we have our midpoint of O. So we don't have anything new to find. We know all 3 pieces, so this is going to be angle, angle, side. PMO, so this is going to have to be triangle QNO. And then our last one, segment ST, segment SV, those are congruent to each other. Segment TU, segment VU. They weren't tricky. They didn't say that we had a midpoint and you had to figure that out. They just told us right away. But that's only 2 bits of information. There's something else we know for sure. Lots of people make the mistake and they think, oh, we have a right angle. It looks like a right angle, but we don't know it's a right angle, so we can't use that. But we do have the reflexive side for sure. So this was triangle TSU, so we have to use triangle VSU. And that was SSS, side, side, side.